people. Testing sound. Testing sound. last time, when I left off, was in the middle of trying to implement the relational operators. Got them added here to the simple evaluator because they're just another binary operation. But I didn't get them added to the parse tree at all because it involves adding another function and blah, 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 blah. And I just wasn't up to it at the time. But now it's a new day, and I am. So, what to do here? Actually, just a bit. I have one thing to take care of here. All right. So I'm wondering if there isn't a way to make this whole thing a little easier, but I'm not going to worry about that right now. See, the thing is there's a bunch of different things about evaluating binary operators and precedence that I'm doing here that I have to repeat over and over again as I parse different binary operators. In particular here, notice there's now assignment, there's a bool term, factor, and I'm going to have to add rel clause to this. Yes, rel clause is going to have to be oh, I even got it wrong. This is what I need here. And then here, that. And then this will go here. No. Yeah, this still belongs down here. So the precedence order is star and divide is highest. Well, honestly, parentheses are the very highest, as it should be. But multiply and divide are the highest, and then the next highest is plus and minus. And then after that, we have the relational operators. And then after that, we have the Boolean algebra operators, not the bitwise Boolean operators, but the logical Boolean operators. We don't have bitwise Boolean operators here, and then that's the lowest precedence. And every time I add a new precedence thing here, I have this function and I have to, we have parse expression. Well, parse expression will have to have still be bool and bool or, but now I'm going to have to change bool term here to no longer look for plus minus. It's going to have to look for all of these other ones here. And then I'm going to have to add another, in fact, parse bool term. I need a parse rel clause is what I need. In fact, this changes to parse rel clause. Yeah, and then I have to add a parse bool term. It's just a mess. So, and they're basically the same function. So I need to think through how I might refactor this so that right, and then yeah. Then we have tokens. And then like this. And like that. And mostly this is just going to copy everything from here, right? Except instead of parsing term, I'm going to have it be parsing bool term. And then this is going to be plus and minus. And rel clause has to go below bool term because it is like so. And then each one of these is going to be look for a term. And here we do want operator plus and minus. Here we should change this to say right. But then this gets changed to plus minus. Yeah. And here was what I'm going to do here. We're going to like that. And then this, instead of plus and minus, one, we're going to have to change this to say not parse term, but parse rel clause. And then this should actually be named this term to like that. And then this should change to operator less equal, greater than, greater equal, equal, not equal, And are there any less than, greater than, less than or equal to, greater than, equal, not equal? Yeah, I didn't think so. Again, left to right ordering. So basically the same pattern all over again, just, different things in here. Then bool terms. Yeah, those are Boolean terms. And then rel clauses, which will include plus or minus. And then this, which will include multiply and divide. Then parse factor handles parentheses. It was easy to add, but it's a lot of duplicate code, and it annoys me. There needs to be a better way to refactor all of this stuff so that I don't have so much duplicate code for all these different precedence levels. I'm going to have to think this through. But that's neither here nor there. I think that this will now compile. Indeed, it compiles. So let's see here. Yep, and here binary operators, which they're all still binary operators. Once the once the parse tree is created, the parse tree implicitly encodes the precedence. It no longer, so all the binary operations are the same, regardless of their precedence, because their place in the tree determines what order they get evaluated in, not their not any kind of precedence calculation. All right then. Oh, I just realized there's a thing that I need to do, so I'm going to quickly switch to, and this time I really do have to switch to switch here. Need to close this. Oh well. All right. That's good. Wanted to make sure I didn't get any unwanted toast. There needs to be a thing that you can do with the GNOME shell to tell it stop with the toast for a little while. But I don't know what that is, so until I figure that out, I'll just turn off the things that send the toast that I don't want. Okay, so this is done. Do I have a main? I must have a main, a normal, everyday main. Let's see here. What was my main? Yeah, this is no, that's not it. It's this, isn't it? But this is just a test. Oh, no. Okay. So I can do some spot tests. And we're going to change this to debug, and then build that. Hey, I didn't change anything. What are you complaining about here? Oh. Oh, it's because in rel with dub info, all the asserts are gone. And so they did not appear, and that's a very interesting name for, or failure mode for the smart rename, because these asserts weren't expanded. It didn't. The parse tree didn't include them, and so smart rename didn't realize that, oh, they were things that needed to be renamed. Well. I guess Amirka is not so interested in programming. Oh, let's see here. Lexer test. Well, the tokenizer didn't like that. Why did the tokenizer not like that? I basically haven't updated this thing at all to handle new token types. It can't compile. I haven't updated this program, and so this program is woefully out of date. Woefully. Blah. Alright. Well, looks like I'm going to have to do a few things here. Let's see here. Let's look at what what does it think needs to be updated. That is what I'm doing. It is true. But this actually needs to be 2 commits. really need to write. Okay, still short enough. Good. I really need to write a mercurial pre-commit hook that tests for my preferred commit style, preferred commit message style. Oh yes, I put these here. Those there. Yep. Why did it catch Clara? Like, one, I shouldn't be imparting anything from catch2 in here, in the CPP file. I have no idea how this got in here, but it shouldn't be in here. Yeah. Focus follows mouse. Stupid thing. Build it again. Does it still work? Yes. Okay, good. Okay, so let's look over this diff. Too many. There. Well, let's create a new window here. Make it only 80 columns. That's 93 columns. 83 columns. 81 columns. Let's make it just exactly 80. Okay. Yep, and this one is the maximum size that's allowed. 67. Okay. So I need to write a mercurial pre-commit hook that tests my first log message here, my first one for being 67 characters or less, and then tests each remaining line of log message to make sure that it is 80 characters or less, because that is my goal, is to make it fit on a punch card. Because, yes. All right. Unfortunately, I don't know. Hello there, Mr. Connor Wright Kappa. I'm working on a programming language. Mostly it's a toy. So that I can... mostly it's a toy programming language. Just to sort of test out ideas about parsers and things like that. That's all it's about. I now am going to be writing some tests to test the relational operator that I just added to the programming language. This is, I don't know if you're familiar with BNF, but this is sort of a BNF style description of the programming language. These are all productions, and then this is the name of the production, and then this is what the production consists of. This means it's optional. There's another, actually there isn't a repeat. I think there is a way you can say things repeat, but usually it's done with recursion. And so as you notice, a lot of them are in fact recursive. But this is a formal way of specifying what are called context-free grammars, which is a standard way of... Standard is the wrong word. A very common way of describing programming languages, and sort of considered like the gold standard. One of the things about grammars that are not context-free is that they're actually a lot harder for humans to understand, as well as computers. It makes the language a lot less clear to read. And so that's why most languages stick with having a context-free grammar. I would have to do a bit of thinking to actually come up with a contextual grammar that made some sense. Let's see here. So anyway, I have a parse for all of the different productions that test to find out whether the incoming token stream matches the productions, and then tries to build up a abstract syntax tree of the incoming expression or whatever. And I just added, as I said, relational operators. I had an if statement and no relational operators. The if statement works. I have tests here for it. And it just is any non-zero expression, and the only data type in my programming language right now is an integer. And any non-zero expression in here counts as a true, and any expression that evaluates to 0 counts as a false. All the values are in fact unsigned integers. Not even signed integers. Only data type the language supports right now. But I now need to add some tests for relational operators. Now we're going to put in the all the relational operators, like 5 less than 2, 2 less than 2, 2 less than 5. And I'm going to do this with all the relational operators to make sure that they all produce the right values at the right times. These are all a bunch of tests. And so, yes. The auto indent doesn't like doing the right thing. And I'm just putting them in here as all the different possible ways that this could Indeed, that's exactly what I want. No, that's not what I want. So, this is 5 greater than 2. No, not 2 greater than 5. 2 greater than 2. Then, nope, 2 greater than 5. There. And it gets it. The AI keeps on trying to complete things, and it hasn't figured out the pattern yet, and that's fine. I'm not really expecting it to. 2, 5, 2, 5, 2. No, less than or equal, greater than or equal to. So 5 greater than or equal to 2. 5, no, 2 greater than or equal to 2. 5, 2 greater than or equal to 5. Each of these will have a false value. And nope. Yep, there you go. That's it. Okay. So this is the input series of input expressions. And we get require that result is not equal to null pointer. Yep, those two are required. And then yep, we're going to do that. Yep, we're going to do that. And then we're going to no, it actually should say 0. And we're going to yep. And no, no, this is not the so the first one, no. No. Yes. No. Yes. 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 No. No. Yes. Yes. No. No. Yes. No. Or no, no, no. Yes. No. There. And that should be a good test. Well, that's very interesting. Zero, zero. So it's it choked out somewhere in here. So 0, 0, 1. So 0, 0, 1. 0, 0, 0, 0, 1. 1. No. 0, 0, 1. 0. 1, 1, 1. 0, 0. 1, 1, 0. Oh, that's why. It did not like that. Expected factor. Yep, it didn't work. So, there we go. Let's try running it again. Okay. Now what's interesting is that this looks an awful lot like assignment. And if 5 were not a literal, if it were actually an identifier, it would be assignment. But because 5 is not an identifier, it isn't assignment. It's a comparison, which is kind of that's just how the grammar works. If you look here, I have assignment as being a very special thing that also uses a straight up equal, and it just has the identifier on one side and an expression on the other. So if you have identifier equals and then expression, that's an assignment, and it checks for assignment in preference to looking for a expression. And so if it can see the statement as an assignment statement, it parses it as an assignment statement. Otherwise, it parses it as an expression. And since this is not an identifier, it is instead a literal, it can't see it as an assignment statement, and so it doesn't parse it as one, it parses it as an expression. But it's a little weird quirk of the grammar. And since all the other tests work, I already know that assignment statements are getting parsed and executed as assignment statements because most of these wouldn't work. So let's check different scenario. So here's what we're going to do. Let's see. What we want to do is we want to come up with expressions where if the precedence is not correct, that the wrong thing happens. You get the wrong evaluation. So here, 5 greater than 2 times 3. If you do it left to right order, 5 is greater than 2 is 1 times 3, so the result will be 3. But if you evaluate 2 times 3 first, which is what's supposed to happen, you get 6, which is actually greater than 5, so this will be false. So it will be true if something is wrong here, and it will be false otherwise. Here, we want 3 times 5 to be evaluated first. There we go. 3 times 2 greater than 5. So 3 times 2 should be 6, and greater than 5, yes. But if we evaluate 2 greater than 5 first, then we will get a false. Or we'll get 3 as a result. Okay. Another one we should test out. So this should be 1. But if we evaluate it from right to left, if we do something silly, or suppose, for example, this has the highest precedence, 2 and 1, so this will be 1. So then it'll be 5 greater than 1, which is true, and then 1 will be less than 6, so it'll be true. But if 5 is greater than 2, well, this is the correct order. And make this 5. This is going to be tricky to think through here. Do you have any questions, comments, observations, Mr. Connor Wright Kappa? Presumably, Mr. Let's see. 5 less than 2. So what we want is an expression that will evaluate one way if it gets all the precedences right, and it evaluates a different way if it gets any precedence wrong. That's just kind of tricky. Ampersand should actually have a lower precedence than this, just like star should have a higher precedence than that. Here's what we'll do. 1 not equal to 2 ampersand 1. Okay. So, if this evaluates correctly, 1 is not equal to 2. Okay, there. 1 is not equal to 2. So that's 1. And 1 equals 1. So that's 1. And so then it should be 1. 1 is not equal to 2 ampersand. So if we do 2 ampersand 1 first, then we get 1. So 1 not equal to 1 is false. 1 equals 1 would be true, and then 1 not equal to 1 would be false. So this should be false if you do any kind of evaluation other than the order in which it's supposed to be. And then we need to come up with something so 1 not equal to 0 will be 1. 1 equals 0 will be false. This will be false. 0 or 1 is true. 1 not equal to 1 is true. True or false will be true. 0 or 1 is going to be 1. 1 is going to be this will be false, and that will be true. Now 1 not equal to 0. Okay. Okay. That should work. We were already testing the precedence of star and whatever in comparison. The star and divide their precedences are being compared to the plus and minus and the Boolean operators. This should be a sufficient test. except that the 1 not equal to 0 or it should be 1. Yep. No. And so then 1 times 3, no, should be 0. 6 should be 1. 1 not equal to 2 is true. 1, and then again 1 should be the right answer here. Okay. Let's see what happens. Now I'm going to go ask the AI. Okay, let's do that. Okay. So we'll ask the AI if it can think of any new tests to add. I don't really care about many of these, but one or two of them, some of the earlier ones, are so the chained relational operators one is in fact a test that should be done. All these other ones are checking functionality that's already basically being checked. But adding, okay, let's add some relational operators to it, which, yes, we could. But no, I'm not going to do that. I don't think it has a lot of value. Edge values, no, given the implementation and the everything, I don't think edge values are useful. Maybe that would be a good idea. The complex ones. So those two maybe. We'll add this one. And yeah, checking that the ASTs are represented correctly when printed out as infix or postfix is probably a good idea. I actually have not added any kind of output yet that involves the relational operators. I haven't updated the infix or postfix printers to support them. It's not that hard to do because it's just like checking for operators and adding more strings, but I haven't done it. So it put them in here, which is fine. Doesn't really matter which order the test cases are in here. So we're going to accept them all. Then I'm going to go through them and make sure that it got it right, because it sometimes doesn't. And I wish it let me edit it before accepting it, because I would kind of like to provide the AI with feedback that, hey, you didn't get it right. And then that would go back to the people who make the AI, and then maybe they would make it better. I don't know. But 1 less than 2, less than 3. So this should be 1. And yes, all that should be 1. Wow. Yes. I see. 3 greater than 2 is 1. Greater than 1 is 0. Okay, yes, that is right. 1 less than or equal to 2 is 1. Less than or equal to 2 is also 1. Okay, 5 greater than or equal to 3 is true. Greater than or equal to 1 is also true. 2 equals 2 is true. Equals 1 is also true. 3 not equal to 2 is false. Not equal to 1 is true. Because this is 0. So 3 not equal to 2 not equal to 1 is 1 not equal to 1. Oh, yes, that's true. 1 is equal to 1, not equal to 1. Okay. I will check out whether, I will just run it and find out whether these strings match and what the output is. And yes, I have to. I also have to go and update the printers for the infix string and prefix string, the visitors, to do the right thing, to actually support the relational operators. 2 plus 3, okay, so 3 times 4 is 12, plus 2 is 14, which is greater than 10. Yes. Yeah, yes, so 1. This is 1. Okay. All of these should be 1. 5 minus 2 is 3, which is, yes, 1. Okay. 6 divided by 2 is 3 equals 3. And, not and 4. 6 divided by 2 is 3. And then 3 is equal to 3. Okay. And then we get to this 4 times 2 is 8. Not equal to 7, which is not equal to 7, which is 1. 1 and 1. Yes. Okay. 1 plus 2 is greater than, yes, 3 is greater than 2. Oh, 2 times 1. Wow, yes. Still 3 is still greater than 2 times 1. Should make this greater than. And 3 minus 1 is less than 4. 2 is less than 4. 1, 1 and 1. Yeah. Yep. That should all still be 1. But I do have to go in here and fiddle here where it says 1 plus 2 greater than or equal to 2, so we have to look for a greater than or equal in here someplace. And change it to a greater than. Change this to a greater than. All right. Oh my. A segment. Oh. Well, yes. But I am kind of curious. Like, a segment fault shouldn't do that. Oh, that's why it does that. Oh. Oh. And where's s underscore op names? I'm going to change something here, which shouldn't actually cause much to change except for now, sadly, I wish that SV, it had a way to do a deduction here, right? Maybe I could do this. And that would work. That does work. Okay. So now if I run it, I will get abort, which is much better. And the abort will happen, well, sadly, it doesn't tell you where the assertion failure happened. Oh, there we go. Yes, there. Much better than the seg fault. Okay. Now we go here into the tokens, and we look at all of our operators and make sure that our operator list matches up. Plus, minus, multiply, divide, bool and, bool or, and here, what we'll do here is just like this, right? And then we'll go and I'll add these down here. Equal Okay, so equal, then we have greater, and then we have less, and then we have greater equal, and then we have less equal, and then we have not equal. Okay. No more assert failures, so that's good. But a failure here, which is not overly unexpected. I was kind of expecting there to be some kind of not working quite correctly with regards to the the printing out of things. Ampersand 1, so let's see what's wrong here. It puts 4 parentheses here. Do 3. Yeah, 3, 2, 1, 2, 3, 2, 1, 0, and yeah, it should only be 3 parentheses. So let's go look at this one here. Find out who's doing the 4 parentheses and who's doing the 3 parentheses. The 3 parentheses is technically correct, but at least it got the parentheses, it got them to match. That's good. One, 2, 3, 4. 3, 4, 3, 2. 3, 4, 3, 2. One. Aha. 0. Okay, yes, this is correct. This is too many parentheses. The too many parentheses one is the AI generated one. But at least it got the number of parentheses correct. Okay, so let's try this again. All right. Well, that's good then. So here, all of our parentheses match up. Good set of tests. The tests make things work. The input, and it's good to have tests to test that the infix and prefix strings are correct for these expressions, so that the relational operators are handled. Does it get all of the relational operators? Does it get greater than, less than or equal to, not equal to, greater than, less than? Yes, it gets all of them, so that's good. Is it greater than or equal to? I think it's missing greater than or equal to. Does it get greater than? It does get greater than or equal to up here. So, okay. All of our different relational operators are covered as things that get output in our strings. So that's good. Okay, yes, this is a reasonably complete test suite. Again, let's check to find out what the AI thinks we've done, because I always have fun with the, yeah, no, yeah. So let's look instead at our diff. And we're going to have to fix some of the brokenness here, but first, I will see about trying to add these, the mercurial pre-thing. Yeah. The mercurial pre-commit hook as well. So, pre-commit hook. There. Yes. 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 No. Now, for these tests here, we're looking for you should be dumber, or you should be smarter than this. The editor should be smarter than that. None of those angry spaces at the end of things. This is a persistent issue that I really hate. So I'm going to search for all the instances. So, gonna fix them all. Because I hate blank spaces at the ends of things. I wish I'd paid more attention. Oh, stop that. Stupid thing. So lines 24, 28, 44, 48. $64. 68. 85, 89. I hate trailing white space. In my opinion, the editor should automatically be removing all trailing, like for C++ especially, the editor should be removing all trailing white space. There is no good reason for any line to have trailing white space. I take that, I'm making that categorical statement, and I think I'm correct about that, but I'm not absolutely certain that that's true. But I think it's true enough. Not that the editor should necessarily enforce that, but the editor should make it very hard to have trailing white space. 265, 281, and 285. There. No more. And we're going to make that a separate change because white space changes should be their own thing. Obnoxious spammer person. I hate that guy. There. White space changes should be in their own commit because otherwise they're noisy. No. And done. Skip remaining changes in files. Now we have a clean diff, and I am going to put a new line at the end. That's one place where I like some trailing white space. I like me some trailing white space. There. Okay. Okay. There. All right then. Well, I'm not quite sure what to do next. I have, oh yes, a looping construct. I should have a looping construct of some kind. I think a simple while loop is probably good enough, but it will need then a break statement in order for you to in order for it to be as flexible as possible. The while loop will need a break statement. All the frippery of for and do while and all of that, I'm not going to add because that's just extra stuff. The main thing is the while loop, which will add the possibility of infinite loops. Which, yeah, I don't want to add any kind of test to find out whether things are in an infinite loop while things are being evaluated. So we're going to skip it. I also am not quite sure how the statement evaluator is going to handle adding a log of statement results when there's a loop. Cross that bridge when I come to it. And I might add some kind of primitive data structure, but that means I have to add data types. I don't know. I don't know if I'll do that. But looping, definitely. This thing definitely needs looping. And then it's actually, once it has looping, It is, in fact, well, more or less a complete programming language. It still has no input or output, but otherwise, it can do anything. Um, so, yeah. Looping, assignment, relational operators, arithmetic. Yep. Maybe I'll get ambitious and add functions. Functions might actually be easier to add than structures. I don't know. I might. I'm not positive yet. But anyway, I reached where I am happy to be at the end of this stream today. So I am going to end the stream. I don't know if any of you have any questions about anything, but if you do, I'm about to end it, so ask now. No? All right. Well, then there's no question asking, so I will stop streaming. And that'll be that. Good night, all. If it's night wherever you are. It is here, technically. Just turned evening. Well, about to become evening.